to solve oblique triangles. Now you guys are probably thinking, what is an oblique triangle? Well, an oblique triangle is a triangle that is not a right triangle. Triangles that are not right triangles. So they have no 90-degree angle. Instead, they might have all acute angles. It might be an acute triangle. Or they might have all obtuse angles. It might be an obtuse triangle, correct? But instead of calling them acute or obtuse, we're just going to call them all oblique. All right? Here's what the formula looks like. Actually, before I write the formula, I'm going to draw a picture really fast because it always is easier to visualize what's happening if you have some sort of picture. So just draw some sort of triangle for me. Label the corners of your triangle A, B, and C. And then you're going to label the sides of the triangle with a little a, little b, and little c. Do you know where those go?
To the side.
Little a is always across from corner A. So this side right here that's clear across from corner A with the big A, little a is this side that's over here across from it. Where would side B be? Side B would be across from angle B, and we write that with a lowercase b. And then where would side C be located? Opposite of C, next to this little side, and that's a little c compared to a capital C here. Okay. Here's the formula you're going to use. The law of sine says that the sine of angle A over the length of side A, that ratio, because that's a ratio, right, when you divide two numbers like that, is equal to the sine of angle B over side B. Yes, Kenny? Okay, also, the sine of angle B divided by side B is equal to the same ratio as the sine of angle C over side C. Does that mean that the sine of angle A over side A is also just equal to the sine of C over side C? Is there any way to solve a problem using all three parts of this formula at the same time? No, you're only able to use two parts of it at a time. Okay? So, and we're not going to be able to use Pythagorean theorem with these triangles at all because none of them are right triangles. They are all oblique triangles, and Pythagorean theorem only works with right triangles. Okay, so if you had information about A and B, but you didn't have information about C, you would just ignore that and do this part. Or if you had information about B and C, but you didn't have information about A, you would ignore that and do this part. Or what if you had information about A and C and not about B, then you just set that equal to that and solve it that way. I'm giving you a formula with three pieces equal to each other, but you only use two pieces at a time. So I don't know if you want to make a note of that. Use only two ratios at a time instead of all three, because I don't know how to cross multiply and solve that way. Okay, you will be given three pieces of information and you will be asked to solve for another piece of information. Okay? If the information you are given is an angle side or an angle side angle, you can definitely use law of sines. The other thing you can use law of sines for is if they give you a side and an angle, then you can solve it using law of sines. Those are the only three ways that those are the only combinations of information that you can use when solving a triangle using law of sines. Okay? We're going to do an example of each one. So let's look at this first one together. Here's the question that's being asked. Let's suppose we have a triangle where the measure of angle A is 47 degrees. In case you've forgotten, that little m means measure of. The measure of angle C is 93 degrees. And side A is 39 in length. We want to find the length of side C. Okay, the first step I always want you to do is to draw a picture. If there is not already a picture, you should always draw one first. So let's sketch a picture. Notice how one of the angles is 93. That's a little bit bigger than 90, correct? So when I draw my picture, I'm going to try and draw an angle that's a little bit bigger than 90, but it doesn't have to be perfectly accurate. It's just a suggestion. Okay, now I'm going to try and match up angles with, like, the letters with the corners and stuff on my picture. Usually it doesn't matter, although this time I really tried to make this angle bigger than 90. So since angle C is 93 degrees, I'm going to label this angle down here 93 because, or angle C, because that one's the one that's a little bit bigger than the others. Then for A and B, it doesn't matter at all. Which one should we have be angle A? I don't care. The top one? Sure. So angle A can be at the top, and that one's 47 degrees, and then angle B can be down here at the bottom. But to be honest, we're not going to do anything with angle B, so it doesn't really even matter. Not in this problem, at least. Okay? Now we have one other piece of information, and that is the fact that side A equals 39. Where would that be located in our picture? Down here on the bottom is where A would be located. Why is it down here on the bottom? Because it's opposite angle A. Now we look at the question that they're asking us. The question is, find the length of side C. Let's go ahead and label side C in our picture. Where would that be located? Across from angle C, between A and B. Someone said hypotenuse, but there really is no hypotenuse because it's not a right triangle. So we don't call it a hypotenuse if it's not a right triangle. Okay. Now let's look at the information we have here. We have an angle, and we have a side. Is that one of the things I told you we could solve? Yeah. So this particular problem is angle, side. So the answer is yes, we have the information we need to be able to solve this. That's something you should always check and make sure you can do. Okay? So yes, we have the right information to use law of sines. Angle, side. Okay. Now we're going to figure out what parts of the formula we're going to use. Do we know anything about angle B, and do we care about solving any B's? No. So guess what? We're going to completely leave that part of the formula out. We're just going to use this part and this part. So I'm going to rewrite that just so we have it handy. So the sine of A over little a equals the sine of C over little c. I just decided to copy the formula down again first. But let's go ahead and put the numbers into that. So what's A? So A is 47, so I'm going to write it instead as the sine of 47 over A. Do we know what A is? A is 39, so I'm going to put that over 39. Okay, the other part of my formula is sine of C over C. Do I know what angle C is? Yes, I do know what angle C is. It's 93 degrees. Now, do I know what side C is? No, so I'm either going to draw an X there, or I can put a little c there, just some sort of variable so that I know that that's what I'm solving for. Okay? So I took the part of the formula that I needed to use, I plugged the numbers in, and now what does it say I should do? Cross multiply. Excellent. Okay, so I'm going to cross multiply so that I have c times the sine of 47 equals 39 times the sine of 93. Now our goal here is to solve for c, so we want to get c by itself. What should we do next? Divide what? Divide what? Right now this says we cross multiplied, so we have c times the sine of 47 and we have 39 times the sine of 93. We need to get c by itself. Right now it's multiplying with something, so we need to get rid of the multiplying by dividing so that we can get c by itself. Joe and Angel, I think both of you probably know what to tell me here. Which one wants to tell me? Angel, go ahead. Perfect. And remember how the sine of 47 is a number? It's not 47. It's the sine of 47. It's a decimal thing, right? Anyway, we're going to divide both sides by the sine of 47. We're just going to write it like that for now. Divide both sides by the sine of 47. So what happens to this one? It cancels out. And that means that c is going to be simply equal to that thing. We just need to make sure we put it in our calculator correctly, and that's the hard part. Okay, are most of you using your iPods for your calculator? Okay, well, if most of you are using your iPods for your calculators, then we need to practice how to do that. First of all, I had a student today that didn't know this because he's new to the school, I think, or something, but he didn't realize that how you get to the big calculator is by turning it. So there you go, just in case you didn't know. Okay, so now if I'm going to type in this problem, I type in 39 times, now I want to do the sine of 93, but the iPod calculator goes backwards. So you have to go 93 sine. Now that answer is the sine of 93. That is not multiplied yet. So now we have to hit equals in order to multiply then 39 times it. Okay? So don't forget after you've got an ugly decimal like that to hit equals so that you get the actual answer you're looking for. Now we're not quite done yet. That's just the top of the fraction. Now what do we need to do to find the answer? Divide by the sine of 47, but because this calculator goes backwards, we have to hit the 47 first, and then the sine, and we get this weird decimal. That's not the answer. The answer is not until you've hit equals. That's the answer. So side C is 53.25 if you want, or I just round it to 3 probably. That's the length of C.